morning children, welcome back to your chemistry class. Today we shall start with a new chapter, that is Haloalkanes and Haloarenes. Let us understand what are haloalkanes and haloarenes. Halo word over here, halo word means halogens, okay? Like for example, we talk about fluorine, chlorine, bromine, iodine, okay? Now let's talk about what are alkanes. Do you know what are alkanes and arenes? Alkanes and arenes, they are hydrocarbon chains, where alkanes, they are straight chains, okay, straight chain, and arene, they are rings. Is this clear to all of you? Thus in this chapter we shall discuss about halogen derivative hydrocarbons. What are we going to talk about? We are going to talk about halogen derivative hydrocarbons. Let us take a simple example over here, like methane. Like methane. This is methane. Okay. If we remove one hydrogen from here and we add chlorine, and we add a chlorine over here, then it is called as, just a minute. If we remove one hydrogen and we add chlorine here, this becomes your halogen derivative, which is also called as haloalkane. For haloarene, we study the simplest ring, that is the benzene ring. We study the simplest ring, that is the benzene ring over here. Okay, so over here when we remove one hydrogen and add one halogen over here, it becomes haloarene. This is what we are going to study in this chapter. Let us understand more in detail as to what are we going to discuss over here. So you already know what are hydrocarbons. I just would like to classify and make you explain it in a better form as to understand what we are going to study here. So hydrocarbons, you know that they are of two types, right? What are they? One is your aliphatic hydrocarbon, and one is your aromatic hydrocarbon, right? In aliphatic hydrocarbon, what do we study? They are again of two types. They are saturated aliphatic hydrocarbons and unsaturated aliphatic hydrocarbons. In saturated hydrocarbons, we study about carbon-carbon linked with a single bond, whereas in unsaturated, they are either linked with a double bond or with a triple bond, right? So here in this chapter, we are not going to study about unsaturated hydrocarbons, but what are we talking about? We have to talk about saturated aliphatic hydrocarbons. They are your haloalkanes when halogen is added to one of your hydrocarbons, which is aliphatic in nature, and it is saturated. Clear? Now, next we come to aromatic. In aromatic, we have to specially study about only the benzene derivatives. Over here, we are going to talk about only the benzene derivatives. I hope this is very clear. So now, what are we talking about in this chapter? We are talking about the hydrocarbons which are aliphatic in nature and they are saturated. They are going to here when they combine with halogens, they form haloalkanes, and benzene derivatives, when they combine with halogens, they are called as haloarenes. Now we further move to the classification of haloalkanes and haloarenes. Okay, so let us understand the classification of haloalkanes and haloarenes. So the first classification is based on the number of halogens attached to a carbon chain. Okay, so I write here number of halogens attached, right? So in this first video, I'm going to explain you the classification of both haloalkanes and haloarenes. Okay, classification will be taught on the basis of both haloalkanes and haloarenes. So here it will be about haloalkanes, and this side I am going to talk about haloarenes. Okay, this will be clear to you, then preparation will be easier. So under number of halogens attached, we come to the first kind, that is called as monohaloalkanes. Okay, monohaloalkanes, what do they mean? When in a straight chain compound it has only one halogen, then they are called as monohaloalkanes. For example, you can take like CH3Cl, okay, or it could be like CH3Cl2Cl. So these are what? These are examples of monohaloalkanes. Similarly, we have monohaloarenes. For example, monohaloarenes could be this. We remove one hydrogen from here and this chlorine is added. Okay. Next we come to dihaloalkanes. Okay. So haloalkanes, they are dihalo also, haloalkanes also, and arenes are also dihaloarenes. So by di word means when two halogens are attached to the straight chain, right? So it can be of two types. Now try to understand. Take an example over here. Like look at this carbon where two halogens are attached to one carbon. Here two halogens are attached to one carbon, and this is termed as gem dihalide. Okay, when two halogens attached to one carbon, it is called as gem dihalide. It is also possible that two halogens, they are attached to two different hydrocarbons. For example, CH2 CH2 Cl Cl. In this case, this is called as vicinal dihalide. What is this called as? Vicinal dihalide, right? Similarly, your haloarenes, they are also dihaloarenes. For example, you can take this, okay, where two halogens are attached, right? Then it is called as dihaloarene. Then the third kind, trihaloalkane. Trihaloalkane, as the word suggests, three halogens are attached to three different carbon atoms. Three halogens can be attached to two carbons also, but here in this case, no word like gem or vicinal is used here. Okay, simply a reaction, a formula is given to you. That is, for example, you can take CH3HCCH2, and here I attach the chlorine. Okay, so here we don't use this word gem or vicinal. It is straight away we call it as haloalkane. Similarly, the haloarenes, they are also trihaloarenes. That is, we take this as an example. Chlorine is added here, it is added here, and it is added here also. So here three hydrogen atoms are replaced and they are substituted by three halogens. Is this point clear? Now coming back to monohaloalkanes or monohaloarenes, they are further divided into two types. What are they? They are further classified on the basis of their hybridization, right? So they could be of Sp2 hybridization or Sp3 hybridization. So let me make you understand now that how monohaloalkanes or monohaloarenes, they are classified under this two, that is Sp2 hybridization and Sp3 hybridization. So let me rub this first and then I shall come back to this classification also. Okay, so depending upon what did I say? Yes, monohalo compounds, they can also be further classified on the basis of what two I said? They are classification on the basis of Sp3 and Sp2 hybridization. Now Sp2 I'll explain you later. Let us first understand Sp3 hybridization. Now Sp3 hybridization is again further divided into three types. Okay, Sp3 is further divided into three types. Let me explain it like this. The first is your alkyl halide. Okay, next one is your allyl halide, and the third one is your benzyl halide. Okay, so under the classification of mono halo compounds, okay, they can be further classified into two. What are they? Sp3 and Sp2. Sp3 can be further classified as alkyl halide, allyl halide and benzyl halide. Let us understand all these three in a more proper manner. So let us start with alkyl halide. Over here, when I talk about alkyl halide, I am talking about this. This is what? Your alkane, and this is the halogen added over here. So here halogen is attached to that carbon which has Sp3 hybridization. For example, over here like CH3Cl, or you may say over here this carbon shows what? Sp3 hybridization. Okay, this carbon shows Sp3 hybridization to which this chlorine is attached. So that is your alkyl halide. Another example is like CH3CH2Cl. So over here if you see, this carbon shows the Sp3 hybridization to which this halogen is attached, right? So the common name is your alkyl halide over here, and the Iupac name over here, Iupac name over here is that of Haloalkanes. This is what we have to study. This is your common name. Okay, this is the common name, alkyl halide of the haloalkanes, which we use as a Iupac name. Now let us talk about what are allyl halide. Allyl halide, by allyl halide I mean, first look at the formula. CH2 double bond CH H. This is your allyl halide, where the halogen will attach itself to the Sp3 hybridization. Okay, and this carbon is further attached to that neighboring carbon which shows Sp2 hybridization. Is this point clear? What did I say? In allyl halide, the halogen will attach itself to which carbon? The carbon which shows Sp3 hybridization, and this carbon is attached to the neighboring carbon which has a double bond, and this is which shows Sp2 hybridization. So this is showing you Sp3 hybridization, and this is showing you Sp2 hybridization. Such a compound is called as allyl halide. Clear? For example, let's talk about an example over here like CH2 double bond CH2Cl. Now look over here. This particular carbon shows Sp3 hybridization, and this is attached to that neighboring carbon which shows Sp2 hybridization. Such a compound is called as allyl halide. I hope this is very clear. Now let's come to benzyl halide. What do we mean by benzyl halide? Over here in benzene, all the carbon atoms, they all have a double bond, right? So we have to first convert it into benzyl. So how to convert it into benzyl? By removing one hydrogen from it. As the word says benzyl, so we have to form a benzyl group over here. So when we remove one hydrogen, what happens? One more carbon is attached over here, and this carbon, let me write here HH, and to this carbon your halogen is attached. So over here what did we see? This particular carbon shows Sp3 hybridization. This particular carbon, it shows Sp3 hybridization. Thus you can say that in benzyl halide it has 7 carbon atoms, has 7 carbon atoms. Okay, carbon atoms, right? 6 over here plus 1 C, which exhibits Sp3 hybridization. I hope Sp3 hybridization is clear to all of you. Now let us talk about Sp2 hybridization. Now Sp2 hybridization is very simple. It is again divided into 2 types. What is the first one that we are going to study over here? Vinylic halide. Okay. Now what do we understand by vinylic halide? Over here your halogen is attached to Sp2 hybridized carbon. That is, let us first look at the formula. It is H2CH2CH like this. Okay. Now this also shows Sp2 hybridization, and this carbon also shows Sp2 hybridization. Okay. So they are termed as vinylic halide. Right. For example, let's talk about one example over here. If I take up this only, CH2 double bond CHCl. Okay, this is what is it called as? Vinyl chloride. What will it be called as? Vinyl chloride. I hope this is very clear. Then its second type. What is the second type called as? Aryl chloride. What do we mean by aryl chloride? Over here, the halogen in the benzene ring, it is attached to Sp2 hybridized carbon. This one will be your Sp2 hybridized carbon, right? So over here we do not have to study about Sp2, but we are more going to focus on alkyl halide over here. So we have finished with the classifications also. We did the classification of haloalkanes and haloarenes. They are monohalo compounds, di as well as trihalo compounds. Then monohalo compounds are further divided into two, Sp3 and Sp2. In Sp3 hybridization, they can be further divided into 3. What are they? Alkyl halide, allyl halide and benzyl halide. What is so particular about all these 3? That the halogen is attached to that particular carbon which has Sp3 hybridization, and in benzyl halide there are 7 carbon atoms. The 7th one is your Sp3 hybridized. Similarly in Sp2 they are further divided into 2 types, vinylic halide and aryl chloride. Over here the halogens, they are attached to Sp2 hybridized carbon. We next move to nomenclature. Now let's talk about nomenclature. Okay. So here in nomenclature, we are going to learn both the common name and the IUPAC name. I am going to take this part in a very short way and give you more of the questions in your assignment folder, where you are going to do it in your register. Okay. So for haloalkanes, let's talk about first about haloalkanes, and then I will discuss about haloarenes, haloalkanes. Okay. Here the common name will be your alkyl halide, as I told you just now, and your IUPAC name, how are we going to call it as? Haloalkane. Okay. Take 2 examples over here. For example, like if I have to write down CH3CH2Cl. So what will be the common name to it? common name to it will be alkyl halide. Now alkyl means methane, ethane, right? So this becomes your ethyl halide is chlorine. Ethyl chloride is the common name of this particular compound. Okay, and if we have to write down the IUPAC name, halogen has to be mentioned first. So what is the halogen? Chloro and alkane. Which alkane? Methane, ethane. So chloroethane. So chloroethane is the IUPAC name of this compound. Clear? Let's take another example like CH3, CH3, and if I write over here Cl. Now this is example A, this is example B. So what will be the common name to this particular compound? Do you recollect anything by seeing this? It shows isopropyl compound. Do you remember isopropyl? So over here, what will be the common name to it? Isopropyl chloride. Alkyl, propyl, but it is of iso types. Okay, so it becomes isopropyl. Halide is your chloride. Then give the IUPAC name to it. The IUPAC name, what have you to write? First, your halo. Halo is what? Here it is chloro. Okay, so chloro, because it is not found on the first place, it is found somewhere in the center, so you have to give the number to it. So where? 2-chloro, whether you write from here or you check from here, so it becomes 2-chloro. Alkane has to be written methane, ethane, propane, so 2-chloropropane is the name of this particular compound. I hope you have understood how to do the nomenclature of your haloalkanes. Now let us talk about haloarenes. Now let us talk about haloarenes. Let's over here the common name has to be written as aryl chloride. Okay, and the IUPAC name will be your again haloarene, right? So let's take one example. If I take this, okay, so write down the common name to it. The common name of this will be what? Aryl. What aryl it is? Okay, benzyl, right? Chloride, because chlorine is there. Sorry, aryl halide should be written over here. Aryl halide. Halide is what? Chlorine. So chloride. Okay, benzyl chloride. What is the IUPAC name to it? The IUPAC name of this will be halo. What halo? Chloro. Arene is what? Benzene. Chlorobenzene. Followed? This is the name, IUPAC name of this, right? Common name, this particular compound is very common and it's commonly also termed as chlorobenzene. Common name to this particular compound apart from benzyl chloride also could be as chlorobenzene. It is very commonly known by this chlorobenzene name as well. Let's take another example. This one, suppose I take chlorine here and if I put it at some other place. Now you already know what place is this. This is a meta place. Okay, so what will be the, now remember one thing, ortho, meta, para, all this name should be given in the common name. Okay, not in the IUPAC, right? So common name to this will be meta, or for meta you can also write as M. Now what is this? Aryl group. What is the aryl group over here? Okay, so meta, it will be dichlorobenzene. Okay, now write down the IUPAC name. IUPAC name of this will be what? 1, 2, 3. 1, 3 dichlorobenzene. Clear? With this we finish off with the classification, right? Next I'm going to begin with preparation of haloalkanes. Now preparation of and properties of haloarenes we are going to do afterwards. Now I'm going to focus only on haloalkanes. Still classification and nomenclature, since everything was somewhat same, so I have finished with the nomenclature of it. Isomerism is not so important. You've already done that in class 11th also. So I'm not focusing much on isomerism, that you are going to read on your own. But now I'm going to begin with the preparation of haloalkanes.